Hello! In this video, we are going to prove the following theorem. Suppose a and b are real numbers. If a squared plus b squared is equal to 0, then a is equal to 0 and b is equal to 0. Okay, now we're trying to prove if this is true, then this is true. And to prove it, we're actually going to prove the contrapositive. That is, we're going to prove if this is false, then this is false. If we can prove that, then that's equivalent to proving if this is true, then this is true. So yeah, let's prove the contrapositive. So we want to prove if this is false, then this is false. So let's suppose that this is false. What does it mean for this to be false? Well, the opposite of saying this is true and this is true means this is false or this is false. So we're going to suppose that a is not equal to 0 or b is not equal to 0. Now from here, the whole goal is to show that this is false. That is, we want to show that a squared plus b squared is not equal to 0. And we're going to show that a squared plus b squared is not equal to 0 in both of these cases. So let's start with case 1, where a is not equal to 0. Now, if we recall, any non-zero real number squared is greater than 0. So this tells us that a squared is greater than 0. If we add b squared on both sides of this inequality, we get that a squared plus b squared is greater than b squared. And any real number squared is greater than or equal to 0, so b squared is greater than or equal to 0. And this chain of inequalities tells us that a squared plus b squared must be greater than 0, right? Whenever we have a chain of equalities that looks something like this, we can conclude from this that a must be greater than c. So applying this idea to what we have here, we have that a squared plus b squared is greater than 0. And therefore, a squared plus b squared is not equal to 0. So, we have shown that a squared plus b squared is not equal to 0 in the case where a is not equal to 0. So now, let's consider the case where b is not equal to 0. And again, we're going to show, in this case, we also have that a squared plus b squared is not equal to 0. Well, since b is not equal to 0, we have that b squared is greater than 0. Adding a squared on both sides of this inequality, we get that a squared plus b squared is greater than a squared. And any real number squared is greater than or equal to 0, so a squared is greater than or equal to 0. And this chain of inequalities tells us that a squared plus b squared must be greater than 0. And so a squared plus b squared is not equal to 0. And so again, we have shown that a squared plus b squared is not equal to 0. So what we see here is, in either case, we have that a squared plus b squared is not equal to 0. So no matter which case we have, it will always be the case that a squared plus b squared is not equal to 0. So this must be true. And therefore, if a is not equal to 0 or b is not equal to 0, then a squared plus b squared is not equal to 0. And so, we have shown if this is false, then this is false. And the contrapositive tells us that that is equivalent to proving if this is true, then this is true. So we have proven if a squared plus b squared is equal to 0, then a is equal to 0 and b is equal to 0. And so this completes the proof. And so yeah, that's pretty much it for this video.